Today we are going to talk about machine learning with Java. You might know deep learning for J is one of the most successful open source library for machine learning purpose in Java. So today we are going to use it in our introduction and the example development. First of all, I'm going to split the talk today into three parts: introduction, quick start, and the summary. So let me introduce the machine learning situation nowadays. You might know Python is still the dominant programming language in machine learning. So many data scientists, software engineers are using Python to do the machine learning. But Java is still the one you can choose. It's not a leading language, but not far behind. You can see, for example, deep learning for J. That's a very successful third-party open source library. By using that, you can also do machine learning in Java. So what is deep learning for J? So you can go to the official website https://deeplearningforj.org. It's a first commercial grade open source distributed deep learning library for Java and Scala. It's also powered by ND4J, which is another open source numerical computing library. So in this video, I'm going to cover hands-on practice with deep learning for J. In terms of the machine learning theories and the principles, they will not be covered. Okay, assuming that you already have the basic understanding and knowledge in machine learning, and you are wondering how you can start your very first network or model development in Java. So we can start here. For development environment, so you need to have JDK 8 and onwards installed. And the IDE, you can use any one you are familiar with. I'm going to use IntelliJ. So in this video, we are going to develop the very first example. I choose to use the very classic example in machine learning, XOR. XOR is a logical operation that outputs true only when inputs differ. So we will see how we can achieve. Typically, we are going to do two things. One is the data collection. Another one is the actual code development with deep learning for J. Okay, you can see here I have already created a project in IntelliJ, deep learning for J practices. You can also do the same. Here I have a class XOR for our example today. This is what you definitely need. NN stands for neural network. This is the dependency you definitely need. When we start the development, the following steps are to be followed. First of all, we need to set up the configuration for the network. Then we can have a network instance. Then prepare the data set. Fit the dataset to the network by epochs times, say 1,000 epochs. It means the dataset will be fed to the network by 1,000 times. After that, we can do evaluation to see the model performance in terms of accuracy, confusion matrix, stuff like that. Evaluation, or you can do prediction. Okay, let's start. For configuration, we need to use neural network configuration builder. In this example, we have pretty small data sets. We need to set mini batch to false for better performance. And then we are going to use SGD as updater. This is a stochastic gradient descendant. We set the learning rate by 0.1. Okay, now we have a list. So this is a layer list. Then we can start adding layers. First of all, we will have an input layer. Before we set up the layers, let me quickly show you the data set. Okay, so you can see this expected input and output. This is pretty straightforward. This is how the XOR logical operation should behave. So in the layers, we want to have an input layer with input with 2 input, and we use 4 output. So in the output layer, we will have 4 neurons as input and 2 output. Okay, so we can create the input layer. Input 2 input, 4 output, and we need the activation function. We are going to use sigmoid. Okay, so this is the input layer. For our case, we use just one input layer, and next is the output layer. Okay, we are building our output layer. Here we are going to use loss function negative log likelihood, and then we set the in as 4, which is same as the output of the input layer, then out as 2. activation function, we are going to use softmax. And weight init function will use the same uniform distribution. Okay, we have 2 layers. Now that we have built the layers, we can have the multi-layer configuration built. Okay, so this is a configuration. And you can quickly see how the network look like. Now that we have the configuration, so we can set up the network by the configuration. Okay, so this is network. Next step is to prepare the data set. We have features and labels. So you see here, we expect the output as true or false. Typically, we are using one hot encoded value for such labels. For example, true, we encode it as 0, 1. False as 1, 0. Let's define the feature array. Okay, so this is our features. 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0. Now we define our labels. We can talk about the one hot encoding more in the future. Now here you can see correspondingly the label will be 1, 0, 0, 1, 0, 1, 1, 0. Stand for false, true, true, false. Okay. Okay, we have the features and labels. Now we need to create the data set. Before we create, we need to add another dependency, which is the ND4J API we mentioned before. Now we can use ND4J to create features and labels. They will be used to create the data set. These are features, the labels. Okay, we have the data set created. Now it's time for us to fit the data set to the model, to the network. We simply do fit. Okay, we have data set fit to the network. Now we can do evaluation. Deep Learning 4J also give us a set of evaluation classes for this purpose. Okay, so we use evaluation class. Now we can evaluate by labels and the predicted output. What we can do is evaluate, so you can see the real outcomes and the guesses. Real outcomes is just the data set labels. The guess, so network output. Get features. What it does here, network output, is by giving the feature set, the network will predict the output based on its learning. Now let's print out the stats of this evaluation. Let's run the code, see what will happen now. Okay, so this is the error you might see in your development. That's because you don't have the ND4J backend in your local development dev environment. What we need to do is add the dependency ND4J native platform. By adding it, run again. Okay, you can see the output here. The confusion matrix, it's not perfect yet. Accuracy, 75%. What we probably can do is, you can try to increase the epochs, say around 1,000 times. See if it will improve the accuracy in the evaluation. Okay, now it gives us the perfect confusion matrix. Accuracy 1 stands for 100%. This is a good result. Okay, let's add one more step for predict. Pretty much the same thing as evaluation. Network output. We're not going to use the features in the data set. Instead, we create a new array. We input 1 and 0. As the feature to the network. Let's print. Ideally, we want to see a 2-element array as the output with a much bigger value in the first element. Oh, sorry, the second element as it's true. So you can see here, the output is two-element array with much bigger value in second one. That stands for true because we encode true as 0, 1, false as 1, 0. So this is how the network predicts the output or the label for the XOR case. Okay, I think that's pretty much it for today. You can see Java is still very important in machine learning. Okay, next time we are going to talk about ND4J and what we can do for data set by using the ND4J library. It's very useful and it's very powerful. It gives you a lot of support in day-to-day machine learning development work. Thanks for watching. See you next time.